Hello everybody, welcome to Computer Science on Paper. This is my notebook. We will see the course Automata Theory and Formal Languages. This is an introduction to formal languages theory, which studies the syntactical aspects of languages. This theory was established during the 50s by Noam Chomsky and other mathematicians, language and scientists. We'll study the two lowest level formats, languages, regular languages and non-contextual languages. What is that? Well, don't worry, we will see. These two classes are useful to describe and define program languages syntax, like Python syntax or Java syntax or C syntax. This theory is also the foundation of compilers design. There are languages which are interpreted or compiled. For example, Java or C are compiled and Python is interpreted. For the ones which are compiled, we need a translation from the source code in high languages to machine languages. Well, machines only understand zeros and ones. We will talk about abstract machines called automata and recognize the languages which will be established. Automatas can decide if a word belongs to a language or not. This will be the main point of this course. We'll also talk about the grammars that produce the words that the automata will recognize or not. The basic elements are the very foundations of the automata theory are alphabets, words and languages. An alphabet is a finite set of non-empty whose elements are called symbols. To name them, we will use uppercase sigma or uppercase gamma. For example, the alphabet 0, 1 is the binary alphabet, only accepts zeros and ones. This is the lowercase Latin alphabet with all the letters in lowercase. This is the number alphabet with from 0 to 9 numbers. Nevertheless, an alphabet with two symbols is enough to represent all kinds of information. Next page. A word is a finite sequence of symbols from an alphabet. Okay, everybody knows what is a word. If we consider the alphabet AB, these are some words. ABA, BAB, whatever, and only one element is also a word. There is no need to be the two symbols in one word. The alphabet, the number alphabet, we have some examples. There is no limit to the size of the word unless this is said. This is a special word which is an empty sequence of symbols. It might sound useless, but it's not. It's called the empty word and it's represented by lowercase epsilon, but I have seen in some papers like lambda lowercase, but it's mainly used with epsilon. What is language? A language is a set of words from a determined alphabet. We will use the letter L to name them, or if there are another languages we can use another uppercase Latin letter. There, here you have some examples of languages. Like L1 have these four words, L2 the same, L3. This is a language with only one word, which is the empty word. But this is still a word because we can see here that this language there is in this in this set there is there isn't any there isn't anything. So this is a language without words, and those are not the same. For example, a language of we can define a language of all words, AB, which begins with A. There are infinite words in this language because there are no limits on the size of the word. Well, those are the very basic foundations and of automata theory, and we will see more next video. Thank you.